Hi, welcome to Micrel TV. I'm Vince Stevie. I'm one of the FAEs here at Micrel, and today we're going to go over some USB power switch products. We'll take a look at how these parts are used and why people use them in products. USB ports are everywhere today. They're in computers, automotive, and even industrial applications. But what's behind the USB connector? We've all plugged our phones into a computer at some time. When you plug your phone into the computer, it synchronizes data, contacts, music, and many other things. But also, what happens over this USB cable is power is used to recharge your phone. Now, we've all had the experience of plugging our phone into a USB port, and the phone continuously tells us it's not supporting enough current or it's not able to charge the phone. That's a very frustrating thing to have happen, right? Let's take a look at why that happens. So if we look at the connector, behind it is data and power. Micrel's products are the USB power switches that control the current limit on the power being delivered to your device. Shown here is an MIC 2009. This device is an adjustable current limit switch. A single resistor off of pin 5 will set the amount of current that can be delivered to your device. If we look down inside the MIC 2009, we'll see how it's built. The main power switch is this FET. It sends current to your device. In parallel with it is a sensing FET, and this FET helps sense the current and then gives an overcurrent indication to the logic inside the part. The parts also incorporate thermal sensors, which monitor the temperature in case the part overheats. Let's take a look at Micrel's USB power switches. Micrel makes a lot of power management ICs, and you'll find the USB power switches under the Power Switching tab. There are many USB power switches. You'll see them in this table, but today we're going to go look at just one in particular, the MIC 2039. The product page for the 2039 allows us to go to the data sheet. The MIC 2039 has a 5% accuracy on the current limit. It's adjustable from 0.2 amps to 2.5 amps, and it's offered in a small 2 by 2 millimeter package or in a SOT23 option. Looking at a roadmap of some of the older and newer parts that Micrel makes for USB power switches, you'll see the MIC 2025. These parts are on many reference designs by other semiconductor manufacturers and are pretty much an industry standard. You'll see that these parts come as singles, duals, and quads. There's also pin-to-pin compatible versions that have latched thermal shutdown. Micrel also makes parts that have latched overcurrent shutdown. You'll see these in offerings from 0.5 amp all the way up to 6 amps. Recently, we've released the MIC 2000 family. These parts are in a common SOT23 package or in a 2 by 2 MLF for enhanced thermal capabilities. These parts come in 0.5 amp, 0.8 amps, and 1.2 amp flavors. There's also adjustable parts. The MIC 2033 and 2039 have recently been released. These have a plus or minus 5% accuracy on the current limit set point. By having the 5% current limit accuracy, this allows you to design your product with more features built into it and know with tighter control when the current limit is reached. We also now have 50 milliamp and 100 milliamp parts, the MIC 2090 and 2091. To round out the family, we've just released also a 1.6 by 1.6 millimeter part. The table shown here gives you an idea of the MIC 2000 family lineup. There are many different features in these parts. Some parts offer a C-slew pin. This is to slew rate control the power as it's turned on. Some offer undervoltage lockout. Others have load discharge features. The reason for presenting this table is because these parts all have what is pretty much a common footprint if they're in SOT23 or in the 2 millimeter by 2 millimeter MLF. We'll take a look now at the common footprint, but we're only going to look at the SOT23 versions. On an MIC 2003, you can see it's a standard 5-pin SOT23. Power comes in and power goes out. There's no enable or other features. If you were to use an MIC 2004, you would now have an enable pin. Then going to an MIC 2005 or the 2015, we add a C-slew pin. You still have the enable and a fault, but now you have the C-slew pin. Then going to the 2006, an undervoltage lockout pin is added. 2007, 8, and 2033 add a current limit pin. This allows you to hang a single resistor off the part and adjust current limit, while at the same time having a C-slew pin to adjust the slew rate, turning the part on. And the 2009 simply offers current limit and fault. The MIC 2000 family has really established a new level of performance and functionality for current limiting USB power switches. It has the highest power rating and footprint ratio of any USB power switch on the market. It incorporates slew rate control, kickstart, dynamic load management, a very low thermal coefficient for the package, and many choices of factory set or user adjustable current levels. Thank you for watching Micrel TV.